So, uh, Hello everyone, my name is Shreyant Ashwin, and today I'm going to do a small presentation on the advantages of doubly linked list. Now, moving on to the first slide in my now moving on to the first slide in my presentation. Before actually discussing about doubly linked list, we should first discuss what a linked list actually is. And when I am saying linked list, I actually mean doubly I actually mean a singly linked list. So what is a linked list? A linked list is nothing but a very fundamental type of data structure, linear data structure in computer programming, now, which we use to implement many other types of data structures and algorithms like stacks, queues, hash tables, etc. Now, what do I mean by linear data structure? When I say linear data structure, a linear data structure is nothing but a way to organize data or to arrange data sequentially in the computer's memory. When I say sequentially, I mean one after the other. So in a linked list, basically, each element of the data is scattered throughout the computer memory. They are not contiguous like array, but they are connected to each other through pointers. But they are scattered throughout the computer's memory. Now, what is the structure of a single linked list? It basically consists of nodes. Each node has a data part and a pointer to the next node part. Now, what do I mean by the data part? So basically, the data part is the actual value which we are trying to express in the linked list. It can be an integer, it can be a float, it can be a string, anything which we want to represent. Now, more importantly, the next pointer. What is the next pointer? Next pointer contains the memory address of the next node. This is how we link the nodes one after the other in a linked list. So it's very important to have the next pointer, otherwise we will lose the we can't have the data structure or link one node to the other node to the next node. Two more important things is the header node, is the head pointer. Head pointer is a pointer to a node of the linked list which contains the memory address of the first node in the linked list. If the linked list is empty, then the header pointer will have the value null. Otherwise, it will have the memory location of the first node in the linked list, and also the last node or the tail node of the linked list has its next pointer set as null to indicate to the user or to the computer program that the linked list ends at the tail node. Now, as you can see through my pointer, I have given a small diagram of this single linked list. These are the nodes. We have four nodes present here, and this is the head pointer. The head pointer has the memory address of the first node, which is 4800. So it has got 4800 inside it. And each node has two things. One, the data. Over here it's 50. And next, the next pointer. So next pointer is nothing but the memory address. So the memory address of the next node in this case is 5000. So the pointer has got 5000 written inside. So that was single linked list. Now we'll move on to our next slide. Now we move on to our main point of discussion, the doubly linked list. Now, what is a doubly linked list? It's exactly similar to a single linked list. It's a linear data structure, but the main point of difference is that inside the structure of the node in a doubly linked list is also similar to a single linked list. It's not intrinsically defined in the computer programming language such as C. We have to define it using struct and type def. So in a single linked list, a node contains only two things: one the data and one the next pointer to link it to the next node. But in a doubly linked list, it has got another node. A node has another pointer called the previous pointer. What is the previous pointer? It basically contains the memory address of the previous node. So these two pointers in each nodes of a doubly linked list allow for bidirectional traversal of the linked list. Now, what do I mean by bidirectional traversal? In a single linked list, we could only move from one node to the other to the next node, and from that node to the next node because we have the pointer to the next node. But we couldn't move backwards because we did not have any pointer linking one node towards its previous node. This exact problem is solved in a doubly linked list by the previous pointer in a node. Basically, we can go backwards as well as forwards. Now we will move on to our next point. So in the next slide, I've basically given a few diagrams to help make it clear. Uh, so this was the single linked list as we discussed previously. Now this is a double linked list. So as you can see, the node is still same as linked list, but it has now got two pointers. One is this pointer and the other one is this pointer. So now each node, for example, let's take this node B, for example. So the B node has got a data field, the B, and a next pointer, just like a single linked list, which points towards the next node. But this second node, unlike in a doubly linked list, also has a previous pointer, which points to the previous node in the linked list. This helps us traverse this way as well and this way as well. Now, as we said previously, in a single linked list, the last node or the tail node is the next pointer in the tail node is marked as null. Now in a doubly linked list, the first node is the previous pointer in the first node is marked as null to basically these are two what do we say, two two stops in a linked list. The last node is also the next pointer in the last node is pointed as null, and the first and the previous pointer in the first node of a doubly linked list is marked as null. This is the head pointer, same as single linked list. Now in my next slide, I start discussing about the advantages of a doubly linked list. The first advantages which I can think of is the bidirectional traversal property of a doubly linked list. As I said previously, by the since in a doubly linked list we have two pointers, one the next pointer and the previous pointer in each node. We can go both ways. From any node we can traverse to the next node or its previous node. This was not available to us in a single linked list. This bidirectional traversal property in a doubly linked list much provides us with a lot of flexibility in designing much more efficient C programs, in designing much more efficient C programs for certain operations, like in which we need to suppose move backward and forward very frequently, or we need to access neighboring nodes frequently. Now we will move on to the next slide. So in my next slide, I'm going to discuss the second very important advantage of a doubly linked list, which is efficient deletion without knowing the previous. Now, for example, we have now uh, let's for example take a linked list, a single linked list in which we have five nodes, and we need to delete the third node, and we have a pointer pointing towards the third node. So what do? We using the pointer which is pointing to the third node, we go to the third node and we delete it. Now the next pointer. Now the problem is we need to the second node in the linked list. We need to update its next pointer to go to point to the fourth node, but that is not possible because from this third node we can't actually access the second node, so we can't traverse backwards. So in a single link is what we need to do is even if we have a pointer pointing to the third node which needs to be deleted, we have to traverse the whole linked list using the head pointer from the first, second, third node. So this will take a big O of n time complexity in the worst case, which is where n is the number of nodes. So this is not good. But in a doubly linked list, the same operation turns to constant time, basically big O of one time complexity. How this happens is, suppose the same scenario, we have a pointer towards the node in a doubly linked list which needs to be deleted. So we delete. So the advantage is not only the next node, we can update the next node. We can also update the next pointer of the previous node, because in the node which is being deleted, we have a previous pointer, which is allowing us to traverse backwards in the linked list. So this is one of the most important practical advantages of our doubly linked list, is that we can delete a certain node in the linked list in big O of one constant time complexity, provided this is very important, that we have a pointer called the target node pointer pointing towards the node which is to be deleted in the linked list. Now moving on to my next slide, which is the third advantage of a doubly linked list over a singly linked list. It's efficient insertion at various positions in constant time complexity. Now this is again another derivative of the bidirectional traversal property of a doubly linked list. So in a doubly linked list, usually we abstract the entire linked list idea as a EDT, as an abstract data type EDT. So in a doubly linked list, we also maintain not only a head pointer, we also maintain a tail pointer, which points towards the last node of the doubly linked list. So over here, if we have to insert a node at any position, may let it be head or tail, or even at the middle, anywhere in the linked list, we can easily do it because each node contains a previous and a next pointer. So we can easily update the required pointers as need be, and we can achieve insertion at any point in the doubly linked list in constant time or big O of one time complexity. But in a single linked list, we would have to the insertion at the head in a single linked list will take constant time because we are maintaining a head pointer. But if we had to insert a node anywhere else in a single linked list, it would need big O of n in the worst, big O of n in the worst case scenario where n is the number of nodes time complexity, because we would need to traverse the entire list from the head pointer to the next, using the next pointers in each node. We need to traverse the entire linked list, singly linked list, to get to the position where we need to insert the node. But in a doubly linked list, since we have bidirectional traversal property, we don't have this problem. Now we move on to the fourth and final advantage of a doubly linked list, which is easier reversal. Now this is not really the primary reason of why we choose a linked list, of why we choose a doubly linked list over a single linked list, but nevertheless it is an advantage in certain scenarios where in certain manipulations where we frequently need to reverse the order of some list. In that the bidirectional traversal property for doubly linked list comes very handy, because using the previous pointer we can easily basically mirror the linked list. And yeah, so that was the fourth and final advantage of using the doubly linked list. Now we will see a few use cases of a doubly linked list. Now, here are some of the important use cases or applications of a double linked list in the computer programming world. The first very important use case which we come across is the one second. Yeah, here is my pointer. So yeah, so one very important primary use case of a doubly linked list is in web browser navigation. For example, in Google Chrome, the most famous uh, web browser we have, to move from web page to the previous web page or to the next web page, we can easily use the back and forward buttons. This is nothing but a doubly linked list where we are traversing to the previous back page using the previous pointer and to the next back page using the next pointer. Now it's much more complicated, but yeah, in layman's terms, this is what is happening be inside the hood as per se. The next use case is in music playlists like Spotify or Apple Music, anything like that. To move from one song to the next song or to the previous song, we again use doubly linked list, the bidirectional traversal property. To also, the third use case which comes to mind is undo or redo functionalities in software. For example, moving from in this slideshow itself, or moving from one slide to the next slide or to the previous slide, we use the back and forward buttons, which is basically we are accessing the previous pointer in the linked list, doubly linked list, or the next pointer in the doubly linked list. So now in conclusion, I would like to say that doubly linked lists are extremely important. They are extremely versatile. They provide us a lot of functionality, a lot of flexibility in in certain operations where pointer manipulation is very important. You need to frequently traverse both directions of the linked list. So that is the main advantage, the bidirectional traversal property of a doubly linked list. In certain the main drawback of a doubly linked list is that we need a slight memory over it, as I've pointed out over here. We need slight memory overhead in each node to store the previous pointer. In a simply linked list, in one node we only had two elements, one the data, int type or a string type or any different types of data, and the next pointer, the next node type, next pointer. But in a doubly linked list, we have also the additional previous pointer, which takes some additional memory. So this small memory overhead per node, which slightly increases the memory consumption per node, in my opinion, is a very small price to pay for the substantial gains in flexibility, which we have in doubly linked list or implemented structures like queues, hash tables or stacks, where reverse traversal, quick deletion, and quick insertion are very important. Thank you. This was the end of my presentation. Hope you guys liked.